everyone, here is the video going over how to solve three variable systems. So we have spent the last few days talking about solving two variable systems, solving for just x and y. So let's talk about what it takes to solve for x, y, and z. So here is the system with three variables. So we're solving for x, y, and z, and our solution is going to be an ordered triple. Instead of just x, y, we also have x, y, and z. So it's an ordered triple that works for all three equations. Now, it is a little bit more intense than solving just a two-variable system because you have several things to take into consideration. I'm going to start by labeling my system by row. So I'm going to label my first equation row 1, second equation row 2, third equation, row 3. And then what I want to do is I want to pick one variable to eliminate. It really does not matter which variable you choose to eliminate, but sometimes one variable is easier to eliminate than another. So for example, if I look at my coefficients for my x's, I have -6, -3, and 10. That would take a lot of multiplication to be able to create an elimination with those coefficients. But if I look at my y's, I have -2, +2, and -2. So those are pretty much set up to eliminate because they're already the same number and opposite signs. So I'm really going to focus on eliminating the y's. So I'm going to make a note that I'm going to eliminate the y's because they do look a little bit easier to eliminate. So this video and your notes are separated into specific steps. Sometimes you will not have it separated into specific steps, but you're essentially doing these steps every single time. So step number 1 is to pick two equations and eliminate one of the variables. So I'm just going to pick the first equation, which we labeled as row 1. And I'm going to pair it up with row 2. So I'm going to go ahead and rewrite my two equations. So my first equation is 6x minus 2y minus 5z equals 2. My second equation for row 2 is -3x plus 2y plus 6z equals 5. And what I want to do is I want to do the same thing that we did with two variable systems, and that's to eliminate them by adding my equations together. So if I look at my y's, they're already set to eliminate because they have the same coefficient or opposite signs. So I can just go ahead and combine everything else together. So -6 minus 3 is -9x. For my z's, I have -5 plus 6z is 1z. And 2 plus 5 is 7. So I'm going to go ahead and we are going to save this equation and we're going to use it later. My step 2 is to pick the same and one different equation to be able to eliminate the same variable. So in this case, I'm going to pick row 2 and I'm going to pair it up with row 3. So the same equation that I'm picking is row 2, and then I'm pairing it up with the other equation, which is row 3, and then I'm going to do the same thing. So row 2 was -3x plus 2y plus 6z equals 5. Row 3 is 10x minus 2y minus 7z equals -10. And I'm going to go ahead and combine those equations together using elimination. And once again, my y's are set up to eliminate because one is +2 and the other is -2. And then when I combine these two equations, it gives me 7x minus 1z equals -5. And then I'm going to go ahead and save this equation for later as well. So step 1, I'm picking two equations to eliminate one variable. Step 2, I'm going to pick one of the same equations that I used from step 1 and pair it up with the other leftover equation from your system. Step 3. So now essentially what I have done is I have created a 2-variable system. So I'm going to go ahead and take my equation from step 1, which was negative 9x plus 1z equals 7, and my equation from step 2, which was 7x minus 1z equals negative 5, and now I'm going to solve this system. So if I look at this system is already set up to eliminate the z's because I have a positive 1z and a negative 1z. So when I combine them together, I have, negative 2x equals positive 2. So then I have x equals negative 1. So that's step 3, is to start the process of solving your 2-variable system. Normally our 2-variable system is set up with an x and a y. This time it's set up with an x and a z, so we're just going to continue to solve. Step 4 is to find the second variable from that 2-variable system. So since I already have x, I'm going to use one of these equations from step 3 to solve for z. I'm going to use the first one. So I have negative 9. I now know that x is negative 1, and I can use that to solve for z. So negative 9 times negative 1 is positive 9 plus z equals 7. Subtract 9 from both sides, and you get z equals negative 2. Our solution needs to be an ordered triple. So we also need to solve for the other variable, which in this case is y. So you can go back and look at your original system, and you can pick any one of these equations to solve for the last variable. I'm going to go ahead and go with the first equation that I wrote down for R1, and I'm going to use that to solve for y. So when I write out my final equation for this one, I have negative 6x, but I now know that x is negative 1, minus 2y, minus 5z, but I also know that z is negative 2, and that equals 2. And then I just have to go through the process of solving. So negative 6 times negative 1 is positive 6, minus 2y plus 10 equals 2. Combine your like terms, I get negative 2y plus 16 equals 2. Subtract 16 from both sides, I get negative 2y equals negative 14, so y equals positive 7. So your final solution is to write it as an ordered triple. My x is negative 1, my y is positive 7, and my z is negative 2. So this system was pretty straightforward because your y's were already set up to eliminate. Let's look at an example where things are not necessarily set up to eliminate, and we're going to have to multiply one or more equations to create that elimination. So here's a new system. So if I look at my variables, once again, I want to choose one that's pretty close to being set up to eliminate, because usually one of your variables is easier to eliminate than the others. I'm going to go ahead and label this R1, R2, and R3. So if I look at my x's, I have 7, negative 10, and 1. That's kind of tricky. My y's, I have negative 5, 3, and 2. Again, would have to multiply several things. For my z's, I have 4, negative 2, and negative 4. So one thing I notice right away is that I have this positive 4 and the negative 4, which is going to help me eliminate things fairly quickly. So I'm going to go ahead and focus on eliminating my z's. So I'm going to make a note that I want to eliminate, I think I spelled eliminate wrong, eliminate the z's because they do look easier to eliminate. So what I'm going to do once again is I'm going to pick two equations to eliminate one variable. So right now I'm going to focus on row 1 and row 2. So row 1, I have a positive 4z. Row 2, I have a negative 2z. So what I want to do is I want to create a positive 4, which we already have, and a negative 4. So in order to do that, my row 1 is going to stay exactly the same, but I have to multiply row 2 by 2. And that's going to create the negative 4 that I am looking for. So row 1, I'm not doing anything with, so I'm just going to rewrite it. So 7x minus 5y plus 4z equals 4. Row 2, I'm essentially taking this and multiplying everything by 2. So that gives me negative 20x plus 6y minus 4z equals 16. And when I combine these two equations together, my z's are going to eliminate. Everything else, I have negative 13x plus 1y equals 20. And I'm going to take this equation and I'm going to save it for later. For my other step, step 2, it says to pick one same and one different to eliminate the same variable. So in this case, I'm going to go ahead and choose, let's see, I'm going to use I'm going to do these two. So I'm going to create a, a positive 4 and a negative 4. So I'm going to take negative 2 times R2 plus R3. I actually think the easier pairing to do would be to pair up R1 and R3 because you have a positive 4 and a negative 4. But I'm actually going to continue going with my original plan because I want to show you the multiplication all the way through because you may have to do that in the future. So I'm going to take R2, multiply it by negative 2. That gives me a positive 20x minus 6y plus 4z equals negative 16. And then R3, I'm not doing anything with, so I'm just going to rewrite it. So I have 1x plus 2y minus 4z equals negative 2. And then let's go ahead and combine. Z's are set up to eliminate. I have 21x minus 4y equals negative 18. I'm going to save this equation for step 3. So step 3, I'm going to go ahead and rewrite the equation that I had left over from step 1. That's negative 13x plus 1y equals 20. My equation from step 2 is 21x minus 4y equals negative 18. And then I just need to solve this system using our normal elimination to be able to solve for x and y in this scenario. If I look at my equation, negative 13 and 21, that seems like it would be way too complicated to eliminate. So I'm going to go ahead and eliminate my y's. I'm going to multiply this top equation by 4 and rewrite it. So 4 times negative 13 is negative 52. X plus 4y equals 80. For my second equation, I'm not multiplying by anything, so I'm just going to rewrite it. So that is 21x minus 4y equals negative 18. And my y's are set to eliminate. So that leaves me with, let's see, negative 52 plus 21 is negative 31x equals 80 minus 18 is 62. So I get x equals negative 2. Step 4 is to solve for the other variable in your 2-variable system. I'm going to use my first equation. So I have negative 13 times x, but I now know that x is negative 2, plus 1y equals 20. Negative 13 times negative 2 is 26. Plus y equals 20. Subtract 26 from both sides, and you get y equals negative 6. So we have 2 out of our 3 variables, so we are almost done. Step 5 is to find the third variable for the 3-variable system. So I can go back and look at any of these 3 equations, and I can use them to solve for my last variable. I'm going to go with row 1, just because that's what I feel like doing. So I'm making a little note. I'm choosing row 1, and I'm going to replace the variables that I do know. So it's 7x, but I know x is -2, minus 5y, but I also know y is -6, plus 4z, and that equals 4. I'm going to simplify what I have. So 7 times -2 is -14. -5 times -6 is +30, plus 4z equals 4. Going to combine my like terms. -14 plus 30 is 16, plus 4z equals 4. Subtract 16 from both sides. I get 4z equals -12. So that means z is -3. So now I have all 3 variables, and I can write my ordered triple. X is -2, y is -6, and z is -3. So as you can see, solving a 3-variable system is quite a bit more involved than solving a 2-variable systems. But if you keep track of the equations that you're using, it shouldn't be that bad. So once again, your goal is to get your 3-variable system down to a 2-variable system, which we have lots of practice solving. Continue to use elimination, and then solve for the last variable, and your final answer is the ordered triple. Hope that helps.